All right, good afternoon. Principles of Engineering. Today we're going to work on Unit 2.2.1, Product Analysis. So make sure you're in your Canvas. Go to the home page, Unit 2, Lesson 2.1. Okay, here's the assignment that we're going to do. So basically you need to bring in something. From home, and you are going to categorize the materials of whatever item you bring in, identifying their properties. Okay. Product 1, team members responsible for bringing product to class, that's you. So you'll examine and discuss this, illustrate the product, illustration, now disassemble your product. All right. When we say disassemble, I don't mean like destroy with a hammer. Meticulously take it apart. It doesn't have to be like perfect, like you're going to put it back together if you're going to throw it away, but make sure that you're taking it apart safely. We're not going to just throw things around. Sketch and describe all the product components. Here you go, illustration. Select one of those components from the product, okay, and from there you're going to test it. So does it conduct electricity? Is it magnetic? Use the nail, just try to scratch it. What's the weight, mass? Hand flexure test. All right, so can you bend it with your own hands, etc. And then you will upload that to Canvas. Best way would probably to do all this in your notebook, snap a photo, and then send it in that way. That is an option. So we're going to go into the presentation now and go over that. Introduction to materials. All right, so introduction to materials. Here you go. What are materials? The idea is that materials are substances out of which all things are made. Okay, the desks you're sitting in, this computer that I'm presenting on, the phone that I'm recording with, my ring, all those are made out of materials. Okay, and currently the MatWeb Material Property Data website lists over 76,000 types of materials. There's even professions out there called materials engineering, which is really just kind of like someone develops something, and then as a materials engineer you develop new materials or existing materials to fit the needs of whatever they're requesting. Okay, so throughout history, cultures have been defined by their ability to select and modify materials. All right, kind of just using your brain. What can we use? What can we not use? In a time where material availability played a critical role in defining culture, war. All right, World War II, World War I, rations, utilizing aluminum, other types of metals when needed would be a good example. All right, so advancements in our materials and technology allow us to either create new materials or improve what we have. So what makes a material? All right, first we have elements. They consist of only one type of particle or atom. So look at the periodic table, and in your periodic table you have aluminum, gold, silver. All right, those are elements. And then, so it's an individual property. The amount of the substance is irrelevant. It's the type of element used. And then our elements can be divided into three categories based on their physical properties, chemical properties. All right, boiling points, melting points, things like that. So we have three different types of elements. We have metals, we have nonmetals, we have metalloids. Okay, so of those metals, okay, they're good conductors of heat, electricity, hard, shiny, reflect light. Think copper wires, metal. All right, normal metal-like objects. They're ductile, have 1 to 3 valence electrons. All right, 1 to 3. Once again, that means they're able to conduct electricity. Non-metal elements would be most gases, okay, at room temperature. Solids that are dull, brittle, powdery. Look at that glass, okay. Poor conductors of heat and electricity. All right, glass is used as a resistor. So Metalloids are mixtures, so possess both metallic and non-metallic properties. Okay, that could be some computer chips. That could be this fancy little thing there. I don't even know what it is. Material composition, compounds. Most substances are compounds. All right, so for example, we have rubber here. We have some aluminum bike. We have a cable that's used, some other sort of foam seating for the seat, rubber for the handles. Okay, compounds are created when two or more elements are chemically combined. All right, vulcanized rubber. All right, tires. Compounds, elements, combinations are not random. All right, so like water, H2O, 1 gram of hydrogen to 8 grams of oxygen. That's a compound. And they can only be broken down through chemical process, not physical process. So I can't physically separate the hydrogen from the oxygen, but they can be separated through other things. So that is one way. Mixtures are non-chemical combinations of any two or more substances. All right, and they can retain their own individual identity and do not have a definite ratio. So the cookie and the chocolate chips, they can be separated physically. Material classifications based upon material composition, distinguishable properties. So common material classification categories. We have metallic, ceramic, organic, polymeric, composite. And we're going to go into those here. Once again, since this video recorded, you guys can go back through and watch it yourself. So metallic materials, distinguishing characteristics, pure metal elements. All right, alloys, thermal electrical conductors. All right, all three. We have saw blade, tire rim, coins, all metallic. All right, ceramic is exactly what it sounds like. Pottery, sinks, toilets, all types of ceramics. These tube-like things on power lines, right? They are typically used to protect against electricity. Here on our space shuttle, the bottom is actually covered in ceramic tiles, and that's used for re-entry. As a matter of fact, that's one of the causes of one of the space shuttles, and one of the space shuttles not making it back to Earth was during its re-entry. There was something wrong with one of the ceramic plates, and it caused the heat from re-entry to get past the ceramics, and that's what caused the explosion. So pretty good stuff as long as it's applied correctly. Clay, brick, tile, sewer pipe, chimneys, china, porcelain, all of those. Okay, those are the silica insulating tiles on the space shuttle I was referring to. Okay, we can apply electrical applications as resistors. So these resistors, rectifiers, thermistors, heating elements for furnaces. All right, all those, the ceramic part inside spark plugs. Organic materials are or were once living organisms. Paper, string, things made from vegetables, made from plants, made from food, animals. Okay. Polymeric, think rubber, think plastic. Okay, low density, mechanical properties include flexibility and elasticity, rubber bands. And then polymeric has subgroups, plastics and elastomers. All right, your plastics, you got thermoplastic, all right, formed into desired shape by applying heat and pressure. Okay, and they can be heated and remolded. Okay, thermosetting is different. So they can be heated up and cooled once, but they can't be repeatedly done. So your thermoplastics are more recyclable, whereas your thermosetting is not so much. Elastomers, all right, here we have vulcanized rubber, so that's what tires are. We have rubber bands, so they can be stretched to 200% of their length at room temperature, can return quickly to original length after force is released. That's kind of an identity of elastomers. And then vulcanization, what I was talking about from tires, is a chemical process used to form strong bonds between polymers. So that is a quality of tires like that. Composites, fiberglass, composed of more than one material, so like the bottom of boats, bike frames, car seats, those are all examples. Layer composites are alternate layers of materials bonded together. Particulate composites are discrete particles of material surrounded by a matrix of another, so that might be one is surrounded by another, whereas layers are on top of each other. Fiber reinforced is composed of continuous or discontinuous fibers, so like car seats that are made from materials that aren't natural, so synthetic. And the material selection is based upon application, properties, budget, how much money do we have, all right? For example, you got the space shuttle. They have millions of dollars, if not billions of dollars, to create this program, all right? At the time when the space shuttle was invented, all right, they had quite a bit of money to use really high quality resources. Whereas in this class, while we have access to some resources, we're a little bit more on a budget than some other organizations. So, what's available to you to be able to build? So, is one of the things that determine material selection. Applications can vary from electrical components to construction at a large scale. So, how much material do you need is going to be an identifying factor. And then what do you need from the materials? Some of the things that we can determine from materials is refined material selection is based upon, so what mechanical qualities do you need? Thermal, electromagnetic, chemical. All right. And then this is some stuff that we can test for, or properties of different types of materials. So how much strength does it have? Hardness, ductility, stiffness. All right. When we're talking about thermal properties, all right, this is affected by heat fluxes, so changes in temperature. All right. Plastic, for example, plastic, especially thin plastic, like if you think of like a cheap lunchbox. All right. If that's left outside in the cold and it gets hit once, all right, it's just going to shatter into pieces. Certain plastics are better at handling different types of temperature. Thermal capacity is the heat storage capacity of a material. So how much heat storage can it have? Thermal conductivity is its ability to transport heat. And thermal expansion is how much a material expands or contracts if the temperature is raised or lowered. All right. For certain things, like inside a car, you don't want too much thermal expansion because then you might end up seizing the motor. All right. And that's what our like motor oils and stuff like that do to help keep the temperature down. And coolant, things like that. Electrical properties, so conductivity, insulators, semiconductors. All right. Thermoelectric means, so thermal responses from electrical. All right, so do we get any heat from the electricity, things like that? Chemical, oxidation and reduction. Metal oxidizes, iron, rust, that's oxidation. Toxicity, the damage effects a material has on other materials. So some materials can withstand other things, but like perhaps DEET for like mosquito spray, you wouldn't want to use around your climbing ropes because it can actually eat away at the climbing ropes. And considering those you use to keep from falling, great distances, that would not be something you would want. And then flammability is another chemical property. Alternative material selections. So alternative materials are being dissolved to solve socioeconomic problems. So what other materials are out there that aren't typically available or typically thought of would fall into that category? That being said, after that PowerPoint is done, your assignment once again is to work with a partner and accomplish this assignment here. All right, and then you would upload that to Canvas. So if you have any questions, ask the sub and let me know if there's any issues. All right, have a good day.